Okay. So I'm Mark Volkman, and I'm going to tell you how to make web components more reactive using a library that I created that is called REC. It stands for Web Reactive Components, WREC for short. And you might want to get a copy of these URLs here because, in particular, for the slides, there are a lot of bonus slides at the end that I won't have time to go over. And if you've got that URL, you can look them over and then contact me at that email address if you have any questions. And all the code I'm going to demonstrate today, you can find at that GitHub URL at the bottom. So I worked at a company in object computing in St. Louis called Object Computing for a long time. I've got 44 years of development experience. I do a lot of writing and speaking. I've got a pretty extensive blog at that URL. And I've written 3 books, the last of which just came out in an early access version last week. And so there's a code down at the bottom there that you can use for 45% off on the book, and you can use the QR code to get to that book. The book is all about developing web components in different approaches, and one of them is this REC library that I'm going to talk to you about today. Some bold claims I'll make. I've had a pretty long career in software development, and this that I'm going to tell you about today, I think is the best thing I've done in my career. You can be the judge of that after you hear about it. You cannot create components for the web with less code than what I'm going to show you today. Please let me know if you think I'm wrong. Send me a message and tell me about that, but I don't think it can be done. You might not care about this if what you're comfortable doing is generating UI code using an LLM and you never look at that code and you don't have to maintain that code. Then maybe it doesn't matter. You could just have it generate whatever it wants and move on with your life. But if you care about having some really clean, understandable, short code, I think this is a great way to go. And so REC is a library that really simplifies development of web components, and the URL for it is there. It's out in NPM, and it's an alternative to other libraries that you might have used like Lit and Stencil and Fast. It really focuses on simplicity and reactivity, and I'll be showing you throughout the talk exactly what I mean by reactivity. So if you want to implement a web component using the REC library, it's really simple. You just have to implement a class that extends from the REC class, and then you define the properties of your component with a static property that is named properties. If you want to style your component, then you define a static property called CSS where you place that, and that CSS will be scoped to that component automatically. Then you add a static property called HTML where you specify what you want to render. And then if your component needs to have methods, you can add them in. And so let's look at a simple example of this. So if you want to get started, you just create a directory for your project and CD into it. You use that command to create a package JSON file. Then you need to install the REC library. Follow that up by installing the Vite library. That's a development dependency, which is why I have the -D. Okay, and then you need to modify the package JSON, and I've stripped out all the things that you don't actually need. The main thing is I need that script dev that runs the Vite command. Then I can create this hello world JS file. And so this is like the simplest REC component you could create. You notice on the first line, I'm importing a function called HTML. We'll see that used in just a second. And then I've got the REC class. Then I have a class that extends from REC, and I have my static property HTML, which is just a JavaScript template literal that specifies what I want to render. It's just an H1 element that says hello world. That HTML tag in front of it is there so that I can get some syntax highlighting and code completion, and I'll talk a bit more about those in a couple more slides. And then finally, I have to say, what is the name of the custom element that I'll use in my HTML to render one of these kinds of components? And it's hello-world. Custom elements have to have at least one dash in them, and so I've satisfied that. So that's my entire definition of the component. I didn't need any CSS, and I didn't need any methods, and there were no properties. So now if I want to use that, I create an HTML file, and this is the most basic HTML I can have. I use a script tag to pull in the code for my component, and then I'm rendering one instance of it with that custom element hello world. Then I can enter npm run dev to run my Vite local server. I can browse 5173 and I get that. Wonderful. And just as a bit of trivia, I wonder how many of you know why in Vite the default port is 5173. Well, in case you haven't heard this before, the Roman numeral for 5 is a V. That's the first letter in VEET, and a 1 looks like an I, and a 7 sort of looks like a T with a part of it broken off, and a 3 is like a backwards E, and so it's supposed to look like VEET. A cool thing about this is I didn't need any kind of build process here. All I had to do was write a little bit of JavaScript, pull it into the HTML, and render my custom element. Now that was a very boring component. We can make it a bit better. How about if I make it so that you could specify the color of the text and the name of the person you want to greet, so it doesn't just say hello world. So this is how I could do this. I'm also pulling in the CSS function now because I want to specify some CSS. And my H1 tag is going to have the color, this.color. Well, this is a very interesting part about rec because any of my properties that I specify up here, I can use them as values of CSS properties, and I can use them directly in my HTML like that. Notice how there's no curly braces or dollar signs in there. It's just a JavaScript expression directly in a CSS property value or in the text content of an element. Up here, I have to say what is the type of these things and what is their initial value. And so if I just render one of these hello world components, it's going to say hello world in blue. But I can change it by specifying the values of these properties. And the way that I do that is by specifying them with attributes. Now, one more thing about these properties, there's many more things I can add to this configuration of each property. And one of them is values. And it's kind of like an enumerated type where I'm going to say the color must be either red, green, or blue. As I have it now, it can be any string. The type has to be a runtime type. So if you're familiar with TypeScript, which probably all of you are, you can't specify things like this is a dog object or it's an array of numbers. You have to give it a runtime type, which is the type that is still there after the real types are stripped away. And so those are the options you have. And the last one, HTML element, I'll talk about when you would use that later. I mentioned that if you use these tags on your template literals, CSS and HTML, you can get syntax highlighting and code completion. Well, in VS Code, if you install the prettier extension or OXC for using the OX format command, and then inline HTML, then you'll get all of those things, the syntax highlighting and code completion, just by putting those tag names in front of your template literals. So I would render an instance of this component like you see here, and you see I'm specifying a color and a name, and then it renders what you see there. A really cool thing about this is that rec ties together attributes and properties in a reactive way. And so if you change one, the other one will update automatically. And so to demonstrate this, I'm going to show opening up the dev tools in Chrome, and I'm going to go to the Elements tab, and then I'll select an instance, and I can directly change the color and the name attributes. So let's look at that real quick. Here is that component telling me hello Earth, and then I go to the Elements tab, and I'll change the color to blue and go over to Earth and change that to Moon. So it updates automatically in that way. Now, the next thing I wanted to show you is that once you've selected an element from the Elements tab, then the variable $0 is set to a reference to that. And so I can say $0.name equals devmio, and it updates. Or I can say $0.color equals purple, and it updates. So attributes and properties are tied together, and they just automatically update when you change one of them. Now, this is the code you would write for a vanilla version of what I showed you. So I'm not using any libraries here. And I've removed all the blank lines because otherwise I couldn't fit this all on one slide. And this only lets me work with the name property. It doesn't even support the color property. So I'd need even more code to add that in. Well, if you've done anything with web components in the past, maybe you're somewhat familiar with this code. This is a mess. And that's why I have the Scream picture up in the corner. Maybe you've looked into web components in the past and you've decided, well, this is just too much work, and that's why I'm going to use Angular or React or Vue or Svelte. But my contention is that this can be fixed with a library like rec. So this is doing exactly the same thing as we saw back, well, it's this one. This is doing the exact same thing, really down to the last detail, the way that that was creating a template and the way that it was using a shadow DOM and the way that it tied together properties and attributes. It's doing the same thing. Now, in Rec, you can place JavaScript expressions in many places, raw JavaScript expressions with no surrounding curly braces or anything like that. It's just looking for this dot some name. And there are 4 places where that can appear: in the text content of an element, in an attribute value, in a CSS property value, that's something that lit doesn't do, and in computed properties that we're going to see later. And so when the values of the properties change, it automatically updates all those places where it occurs. Now you might be wondering, is this really a safe thing? Like, how come I don't need to surround them with curly braces? Maybe I should do that. And is it really sufficient to just search for all occurrences of this dot some name? Maybe there'd be a case where I really want that to appear in my UI, this dot something. Well, the answer, as far as I can tell, is no, that's never going to happen. Now, you might have a sentence that ends with this dot, but it doesn't have another letter immediately after it. You'd have a space and then go into the next sentence. However, if you find yourself in that situation, if you use this dot dot something, that's the escape mechanism, and then it'll just output it as is with only one dot. Rec gives you an easy way to get the value of an input or a select element that you commonly use in HTML. So the value attribute gets a two-way binding if you set the value to a reference to a property in your component. And so then it just automatically updates. So here I have a circle calculator component. It's going to calculate the area and the perimeter of a circle. And it has just one property, the radius of the circle, which is a number, and it starts at 0. Got a little bit of CSS. There's nothing special going on there. And then over in the HTML that I want to render, I've got my input element, and the value is associated with my property. And it knows that because I said this dot and then radius, which you see over there. And then here, I've got a JavaScript expression directly in the text content of an element, the span. And I'm going to compute the circumference of the circle, and down here, compute the area. And so I don't write any code to do event listening or update the DOM. And so if I go over to Chrome and go to this tab, here's my circle calculator, and I put the focus in that input, and I'm just hitting the up arrow, and it recalculates everything for me as that value changes. All right. I lost my full screen thing here. Where'd my triangle go? There it is. Okay. All right. So I think this is really magical that I get all of that and I didn't have to set up any event handling. It's just automatically giving me a two-way binding between the property value that is modified by the input and then recalculating all of those spans. You get a similar thing when you have a rec component that has child rec components. The parent can pass its properties down to a child, and then that causes a two-way binding. And so if I change that property in the parent, it automatically updates the corresponding property in the children, and vice versa. And so there's no event dispatching going on here. It's just directly handling those kind of changes. And so here's an example of that. Toggle buttons is a component that extends the rec class. It has two properties, labels and values. Labels is a comma-separated string of all the labels that I want, and it's going to give me these buttons that you see here, so red, green, and blue. My CSS, I'm not showing that detail. There's nothing interesting there, but notice how my HTML is just a call to this.makeButtons. So an interesting question here is, how would it know to call that again and give me new HTML? Like, what if I change labels to a different comma-separated string of color names? I'd want it to replace those radio buttons? And the answer is this used by. So you can tell each property, if you change, these are things that you have to reevaluate because of that change. And so if I change the labels, it's going to call make buttons again. Now, make buttons just splits that comma separated string, and I iterate over those. And for each one, I'm going to output this HTML for a button. And you see I've got 3 buttons over there. And this class is going to be this expression. And this is interesting because the value of this dot value may change at some point. And if it matches the label that I'm on, then I want the CSS class selected to be applied. And that's what makes it have a light green background. But otherwise, I don't want that class applied. And that'll be reevaluated automatically anytime the value of my value property changes. And then when I click any of those buttons, it's going to call handle click. And that's just going to take the text directly off the button and make that be the value of my value property. Okay. And then here's a component that is going to use that one. And so it has a property color, and it starts off with a value of red. And then I'm going to render 2 things. Now, you already saw the hello world component where I can give it a color. But here I'm passing my color property that belongs to my app. And so that's going to update this anytime it changes. And then I have an instance of toggle buttons from over there, and I'm using that same property. So when these buttons come up, if I click on green, it's going to modify that inside toggle buttons, but that's going to reflect back to the parent. And because it went back to the parent, it's going to go down to hello world, and it's going to update that. So let's see that in action. Okay, now there's an extra thing happening here, that alert that popped up, and I'm going to show you the code for that in just a second. But that's just telling me that toggle buttons value changed from red to green, and there's the change, and it updated the text. And I'll do the same thing by clicking on blue. Okay. So that, I think, is incredible. I wrote almost no code to make that happen. It just automatically wired up, keeping those properties in sync. If you want to have events dispatched anytime the value of one of your properties changes, then all you need to do is add dispatch :true to the description of your property, and it'll dispatch the events for you. And those events, there'll be change events that have a property called detail, and detail is an object that has those 4 properties. So it's going to tell me what's the name of the element that had the change, which property in that element changed, and what was the old value and the new value. So here is what I actually did in my toggle buttons component. I said that I wanted to dispatch events. And then over in my HTML, where I rendered the my app component, I added this bit of JavaScript. And so I go into my document and I find this element, the my app element, and then I have to go inside it. Now, if you've worked with web components before and you know about the shadow DOM, you know you can't just query into a web component directly. Once I have a web component, I can ask for its shadow DOM, and I can query into that. And so that's how I find the toggle buttons. And now I'm adding an event listener, and because I told it to dispatch change events, I can listen for that. And when I get it, I get the detail property and destructure that, and then I display that alert. So if you need to know about properties changing, all you have to do is tell it to dispatch those events. Now, this component I'm going to use in an example coming up. And so let's just review this and hold on to that until we get to that example. But it's a number slider, and so it's going to have a label, and then it's going to have an input with a type of range, and I can grab the thumb and drag it around between a minimum and a maximum value. And so I want to be able to specify the label that comes in front of it. And the reason I want to specify a label width is that if I stack a bunch of these vertically, maybe I want the labels to all be right aligned and line up perfectly, and that allows me to do that. The min and the max have default values of 100 and 0, and then value is where you've dragged the slider to. All right, and then the HTML I need to render for my number slider, I need a label that displays this dot label. And then my input is tied to this dot value, But an interesting thing here is this bit that I've added, this colon input. By default, it's listening for change events, and that means it won't actually update the value property unless you move the focus out of the input or you press the return key. But I want to get the new value every time the user's dragging it as they're dragging it. And so I want to listen for input events instead of change events. And that's the rec way to tell it which event you want to listen for. Okay, so now we've got our number slider, and you'll see just in a bit here how I'm going to make use of that. But this is how I could render a number slider. And I would pass into it some property in the parent component so that that value can come back out and I can use that for something. All right, so rec supports computed properties, and I need that for my next example. If you just say computed equals some JavaScript expression when you define the property, then anything in that expression that changes, it'll cause it to compute a new value. And so in our example, we want to modify a color value. Well, rec tracks all the properties that a computed property uses, and it recomputes it anytime those change. It detects dependency cycles. So you could try to make this thing fall into a loop where property A depends on B, and B depends on C, and C depends on A. But rec detects that, and it will throw an error if you do that. All right, so let's jump into our example. I want to define a color picker, and this is going to have 3 sliders, one for red and green and blue. And so I have those values here, red, green, and blue. I've got my label width that I'm going to pass into 3 instances of that number slider. And then here's my computed property. The color is a string, and I compute it with this expression. Now, you might be wondering, why do I need those backticks there? I got the whole thing surrounded in double quotes. Well, the reason is that what's inside the double quotes is a JavaScript expression that I'm going to recompute anytime something it references inside changes. So if the value of this dot red or green or blue changes, I need to build a new string using this template literal. Okay. Got my CSS, and the most interesting part of this, a bunch of this is just some flex layout details, but down here on the swatch, I'm going to display the square to the left of all the sliders so I can show you the current color, and the background color of the swatch is this dot color. And so if I change the value of red, green, or blue, it's going to recompute this, and then that will be the color that I use for the background. So here's the HTML that I want to display. I have a div with an ID of swatch with nothing in it. It's just going to be styled to have a height and a width of 5 rem and a certain color. And then I have 3 of my sliders, and I have 3 calls to the function makeSlider, and I'm just passing in red, green, and blue. Notice all those start with an uppercase letter, but down here in my number slider, I'm going to change that to lowercase. And the reason is that the names of my properties are red, green, and blue with no uppercase letter. Okay, but the label itself is going to start with a capital letter. They all have the same label width, and then I'm setting their maximum to 255 because that defaulted to 100. And now I've got my color picker. And this is what it looks like. So let's see that in action. Okay, so I'm going to drag the red, and drag the green, and drag the blue back. Very quick updates. Okay, and notice that that changed the color of the text that's down here. And if I drag the size slider, I can change the size of that. Now, we haven't seen that bit of the code yet. That's what's next right here. So color demo has 2 properties, color, which is a string, and size, which is a number, and it starts at 18. And then in my CSS, I have some styling for the paragraph tag. That was that part at the bottom that you saw. And its color is this dot color, and the font size is this dot size, that many pixels. Okay, and then the HTML that I want to render, I want to have a color picker, and I need a number slider where I'm going to specify the size. And notice its value is this dot size, and so I'm tying it over to here, which is used here. And then the color picker has this dot color going into it, which is right here, and it's used right there. So with this HTML, where I pull in that code that you just saw and I render one instance of that, I get this UI that I just demonstrated. I think this is incredible how little code I had to write to do this. I didn't set up any event handling, and yet all these things were tied together, and changing a property in one bit of it cascaded it all over and just made this update automatically. Rec has some interesting support for working with forms. What you're used to is inside a form element, you have input and select and text area elements. And when you submit the form, it takes their values and submit those across. And the way that you specify what the form keys are that get sent over to the server, well, I'll show that in just a second. But in a web component, what you need to do to allow it to contribute data to a form is you need this static property form associated equals true. And this is not specific to Rec. All web components need to do that if they want to contribute to a form. In Rec, if you want to contribute a single value from your web component, then if the name of that property is value, then all you need to do when you use an instance of that component is specify a name attribute. And that's exactly the way input elements work in normal HTML. And so that just stays the same. But you might have a case where you want to submit more than one value in a form. Like in my color picker, if I want to submit the red, green, and blue values, then that's more than one value. And so the way I do that is by adding an attribute called form-assoc. And so we'll look at an example of that. So in my number slider and in my color picker, I add that static form associated equals true. And then in a parent component that uses those two, I could have this. I've got a form element and I'm posting to some URL. I've got my number slider and I've got name. And that works because number slider does have a property called value. And so when I submit it, it's going to add a property named score, whose value is whatever you pick in the number slider. In my color picker, I don't have just one property named value. Instead, I have the properties red, green, and blue. And so with this form-assoc attribute, I say for red, use form key R, and for green, use G, and for blue, use B. Then I have the normal buttons you have in a form. I've got a reset button and a submit button. So for the number slider, I'm sending across the key score. And for the color picker, it's the keys R, G, and B. Now, you can do this without the help that Rec is giving you in a vanilla web component, but it's way more complicated. You have to do all the crazy things that I'm listing in that yellow box. And I won't take the time to go through it. Just note that there's a lot more to do than what you have to do with Rec. So let me demonstrate that one. So that's right here. It looks like what you saw before, except now I have a score slider as well as my color picker. And so I'm going to change the score, and let's change the red and change the blue. I didn't change the green. So we got 55, 110, and 164, and I'm going to submit that. And I submitted this to an endpoint that just echoes back to me what it received. It's really nice for debugging. And I can see here the values that I got for B and G and R and the score. All my data came across. If I go back, it's going to reset that. So everything's back the way it was. But I also have a reset button, and that works. And Rec did that for me. I didn't have to write any code to make either the form submission or the reset work. Okay. And the last big feature I want to go over is support for state. So Rec state is a class provided in the Rec library that lets you share data with multiple components and keep them in sync. It can also optionally persist that data to session storage if you need that. That's useful so if the user refreshes the browser, you don't lose the data. And this is removing the need for prop drilling. I always could put my data in a high component in the hierarchy and just pass it down through all the levels. But if I use this Rec state class, then I don't need to do that. And so we saw the hello world component earlier, and we saw a component similar to labeled input, but here's that one. It's kind of like the numbered slider. The main difference is that my input here is of type text instead, but it's got a label and it's got an input that you can enter a value into. And so what I want to demonstrate here is that I could have HTML that renders a labeled input and my hello world component. And then I'm going to insert some code right here that demonstrates using rec state. So what I'm doing is I am importing the rec state class. I'm importing these two components that I'm using. Then I create an instance of rec state and I give it a name. It's called demo. And the data is an object that this just has a name property, but you could have as much data as you want in your state object. And then I get a reference to my labeled input and I tell it that I want it to use that state. And I'm telling it, well, how do I map from the properties of that component to the properties in my state? And so I'm telling it, hey, that thing that I called name that was in the state object, it's called value inside the labeled input. And then for hello world, well, I'm lucky here because it already has a property called name. And so I don't have to tell it what the mapping is. And then finally, I'm going to find a button that I added right here. And if you click that button, I'm going to directly modify the value of the name property and set it to world. Okay, so I could have added a second argument there of true to say that I want it to persist to session storage. And here I'm mapping the labeled input value property to name. And here I'm mapping for the hello world component. This is what it looks like. And so let me demonstrate this one. Okay. And here I go into my labeled input and I'll change that to dev mio and it updated. So it put that new value into the state. And because my hello world component is also using the state, that just updated. If I click reset, that's directly modifying the name value in the state. And then they both went back to the way it was before. Now, the other cool thing about this is if I pull up DevTools and I go in the console here, I can grab that state object. So I'll just say state equals rec state.get and find me that state that is called demo. Okay, and now I've got it. If I want to see what's in that, I could just say json.stringify state, and there it is. I could change it. State equals my name, Mark. Bam. I changed the state directly, and it updated the UI. Okay, and all I had to do was tell it how to map those things. And notice that I didn't modify the components themselves. They don't know anything about state. It's from the outside that you tell it how to map the properties of that component to properties in your state object. So this is what we just looked at. I can get a reference to a state object from any of my code just by its name. I can dump it out. I can see the value. I can modify the value. And everything that uses that state just updates automatically. All right, just a few more properties that rec has. It uses slots just like any web component does. That's not different. So you can inject HTML into your components. There's a ref attribute that you can specify on properties to say, when this gets rendered, I want to get a reference to that DOM element so that in my methods, I can modify it directly. It supports server-side rendering to get faster initial rendering and better search engine optimization. So that's a built-in feature. So just summarizing the benefits of rec, I think it really simplifies creation of web components. It has more reactivity than even the lit library does. You get DOM updates when properties change. It just happens automatically. Reactive CSS through JavaScript expressions that are the values of CSS properties. Computed properties, if any property they use changes, it recomputes and then updates the DOM based on that. Two-way bindings between attributes and properties. Change an attribute, the property updates. Change the property, the attribute updates. Two-way bindings between form controls and properties. So an input can be tied to a specific property in my component, and when the user interacts with the input, that property changes, and vice versa. Syncs between parent and child components. So a parent can pass its properties down into a child component, and they sync back and forth in both directions automatically. It's easier for me to contribute data to forms and form submissions. All I have to do is say, how do the properties in my component map to the form keys that I want to be submitted? And finally, what we just saw is how easy it is to share state between components. All I have to do is create a state object, throw some data into it, and then tell it how those properties map to properties in each of my components, and it wires up everything so that the updates happen automatically. I wish that I had about an hour more to talk about this. That's why I have so many bonus slides, but I'll just point out that there are some scripts that Rec provides that simplify checking a bunch of things for you, and there's a VS Code extension that runs all of those scripts for you. So there's some resources you can check out. That URL is to a series of 8 videos I created on this library. They're all about 5 minutes long, and so if you want to watch those, you'll get a really quick overview of the main features in Rec. I've got a blog page that talks about it. You can find the library and NPM there. There's the GitHub repository, and you can email me any questions you have about this.